So water is flowing into a vertical cylindrical tank at a rate of 24 cubic Dutch. Oh my god. This is supposed to be cubic feet. And if the radius is 4 feet, then we will find how the we'll find the um, we will find how the surface rises, or how fast it rises, right? So just like before, we need to draw a diagram. But it says here it's cylindrical tank, so we need to draw a cylinder. Cylinder looks like this. If you copy paste it, so you will have no hard time doing it. Looks like that. Then, according to the given, water is flowing into the cylindrical tank. I hope I am visualizing this video because I am really having a hard time drawing the diagram. I'm using a mouse. So this will become 24 cubic feet per minute. So we have a radius of 4 feet. So the question here is how fast the surface is rising. So this will be quite a quiz, an easy question because we will also find the dh over dt of this question. For short, we will look for the rate of change of the water rising in the cylindrical tank. So let's write all the given equations. We have dv over dt. Oh, sorry, that really looks terrible out there. We have 24 feet per minute. And we have a radius of 4 feet. So that's the given. That's all the given in the question. So the next step is to identify the volume of the cylindrical tank. So the volume of this, that will be pi r squared times height. So we need to substitute anything. So we have volume pi. So we have the radius of 4 squared times the height. We don't have a given height, but that won't be necessary in this question. So we have volume is equals to pi 16h. So that's the last part. Then after this one, we will find the rate of change. This is the exciting part of this question. The topic. So we derive it with respect to time. We all know it will become dv over dt. That will become pi. Then derive we derive this one. That will become 16. Then we derive h, will become dh over dt, because that is the one we are looking for. Then we substitute dh over dt with 24 since we have the given right here. Fine. So let me put some space in here. So we have 24 plus to pi of 16 dh over dt. So simple as that. We will, oh, don't forget to put a parenthesis in here. Because if you put it like this in your calculator, you get math error. So you divide this by pi over 16 in order for this to be cancelled. This will be cancelled, and dh over dt. Let's divide this one. 24 over pi of 16. Then we got 0. Oh, that's that dot 0.48 feet per minute. Therefore, we have our final answer for this question. I hope you get it, because I'm really having a hard time writing in this computer. So we have a quite complex problem right here. Let me move this little bit. I hope we have some space in here. So we have our last example of the topic. Uh, a ladder 20 feet long leans against a vertical wall. If the top slides downward at the rate of 2 feet per second, find first how fast the lower end is moving when it is 16 feet from the wall. And letter B, we need to find the rate of change of the slope of the ladder. So we need to do the first step, which is visualizing the problem itself. So we have a, let's assume that this is a wall and this is the ladder. Because it is leaning against a wall, it will make it look like a ladder so that we have a better visualization. So let's assume that's the ladder. Oh, that's really terrible, but I hope it visualizes very well. Oh my god. I'm really having a hard time drawing this. So this will become 20 feet long. That is 20 feet. And this will be 16 feet. According to here, 16 feet from the wall, so we have a base of 16 feet. And we have a rate of change. So let this be y and let this be x. So there are changes in y because it slides downward. So we have change of y. No, that's really terrible looking out here. Since it is decreasing, it will become a negative. So it will become negative 2 feet per second. So we have, I guess we have visualized it, right? So our first step here is to find this side, the y side. So how do we do that? So first, we will have to use the Pythagorean theorem. So we have x squared plus y squared equals to z squared. Let this be y right here. This is y, this is x, and this is z, the ladder. So we need to substitute the x. We have the equation of the x, which is 16 squared plus y squared. So we have a z of 20 feet, which is visualizing the ladder. So we have 20 squared. Then after that, we need to move it to have more space. Then, let's see about that. We have 16 squared. We have 256 plus y squared. So 200 squared, that would become 400. So next step is to make this one disappear. So we subtract it. And we also subtract it right here. So this will cancel. So we only have y squared is equals to 400 minus 256. That will be 144. Then in order to find the final answer, we will have to square this one. Oh. So the square root of 144, that will become 12. So therefore, we have a side here equals to 12. So we have our sides now. So all we need to do is to find the rate of change in this portion, which is the x. Change of x. Oh. We will look for this one. So how do we do that? First is we use implicit differentiation with this one. So we have to use Pythagorean theorem again. So we have given here of 20 feet, right? So we put it like this: x squared plus y squared, and that become 20 squared. Then we differentiate this implicitly, so it will become 2x. We derive this with respect to time because it is the main goal of the topic. So we have 2x dx over dt plus 2y dy over dt. So 20 squared. If we derive this one, it will become 0 because this is a constant and a derivative of any constant is 0. So since we are looking for the dx over dt, or the change of x for short, we will substitute everything we have in our equation. Therefore, the 2's will be cancelled. So we substitute x, which is 16, then just bring down dx over dt, then plus y, we have y of 12, then dy over dt, but this is, as it is given here, we have negative 2 feet per second, so we need to put negative 2 in here. That will become 0, then multiply these two, it will become negative 24, then bring down these two. So next one, since it is equated into 0, so you need to transpose this one. So it will look like this. The negative sign will be gone, and this constant will be moved in here. Then after that, we look for the dx over dt with ease. So we divide both sides by 16. These two will cancel. We have our final answer of the first goal of the question, which is we have 3 over 2, that will become 1.5 feet per second. This will be our letter A.